Hi everyone, the topic for our presentation today is metallic bonds.
Definition of metallic bond. Metallic bond is a strong force that is resulted from delocalized electrons grouped in a freely moving electron sea that surrounds more than one positively charged metal ion. As we can see from the figure, we have the positive charge of the protons in the nucleus and we have electrons that are free to go. So they don't want to get too close to each other. They're going to repel to each other due to the electrostatic attraction in between cations and the electrons. So what they do, they simply drift around and constantly in motion. So what you create is the sea of electrons that have a negative charge, and the protons are going to be held on the inside of that. So this is some of general information. Paul Drude proposed the idea of the sea of electrons metallic bonding theory. Metallic bonds occur among metal atoms such as pure metals, alloys, and some metalloids, whereas ionic bonds join metals to nonmetals. Metallic bonding joins a bar of metal atoms. For example, aluminum foil and a copper wire both exhibit metallic bonding in action, and some metals can form other type of chemical bond between their atoms. For instance, mercurius ion can form metal-metal covalent bond. So we move to the characteristics and properties of metallic bond. So first of all, metal is malleability. So what is meaning of malleability? Malleability is you can hit them and they are going to flatten out without breaking. Why metal is malleability? This is because the delocalized electrons are always there. It always holding together and shifting positive ion. So why ionic crystal is not malleability? It is because no matter how you hit it, the same charge will line up. For example, positive with positive. So this is cause a great repulsion that makes the ionic crystal breaks. Here the example of malleable metals. As we know, metal is malleability, so it also ductilicity. So what is meaning of ductilicity? Ductilicity is if we pull it, it's going to stretch rather than break. Metal is luster. So what's luster? Luster is like shiny. So why metal shiny? Free electron, which is electron valence, absorb energy from the photon of light, which can easily jump to a higher energy level. Then, when they fall back down a level, the energy is re-emitted as light. The color of metal is determined by the wavelength of light, which is re-emitted. Next, they also are good at conductivity, conducting heat and conducting electricity. Due to the mobility of the delocalization electrons makes metal a good conductor of heat and electricity. So, for conducting electricity, it is because the delocalized electrons that are moved freely through the vacant space between metal ions. Applied voltage causes the electrons to be displaced in the given direction. For conducting heat, if metals are heated, the delocalized electrons in the sea of electrons area absorb heat energy and it will increase their vibrational motion. Thus, delocalized electrons allow heat transfer. Next, metals are high melting and boiling point. Solid at room temperature. In order to melt solid to liquid, some of the attractions holding the metallic crystal together must be broken. In order to boil liquid to gas, all the attractions holding the metallic crystal together must be broken. The attraction of the core atoms for the delocalized electrons is strong because it involves full charges. Thus, metals generally have high melting points and boiling points. So here the example of high melting and boiling point. The strength of the metallic bond is inversely proportional to the size of the ion and directly proportional to the number of valence electrons on the metal atom. The melting and boiling points of metals increases across a period but decreases down a group. here we have two tables, which is alkaline metals and alkaline earth metals. As we can see, group 2A elements, alkaline earth metals, have higher melting points than group 1A elements, alkaline metals, due to the smaller size, and the electron C has twice as many valence electrons. And lastly, metals are malleability and also high tensile strength. So what is the meaning of tensile? Tensile is metals can be stretched to some degree without breaking. So here the example of metal that have high tensile strength, which is tungsten.
Before we get into details about the features of cooking pan, let us first learn about alloy, which is the main substance that is used to make a cooking pan. Alloys. Metallic bond occurs among metal atoms and also among different elements. A mixture of two or more metals is called an alloy. Since alloy are held together by metallic bonding, it also possesses metallic properties, which is why it is commonly used in commercial products. There are mainly two types of alloy. The first one is substitutional alloy. An example of it is brass. Brass is made up of zinc and copper. When these elements are mixed, zinc will replace or substitute some of the predominantly existing copper atoms. The next one is interstitial alloy. Example of interstitial alloy is steel. Steel is made up of iron and carbon, which when they are mixed, carbon will fit into small spaces in between the predominantly existing iron atoms. The main mixture of a cooking pan is an alloy, known as stainless steel, which has steel composition with addition of chromium. The characteristics of stainless steel are as follows. As you can see in the diagram, because of the metallic properties that it possesses, most parts of cooking pan are made up of alloys. This is to enhance the durability and overall performance of the cooking pan. Rivets. Rivets are used to join different parts of the pan together, such as handle to the lid or to the pan, and are made up of a type of alloy called copper nickel to improve strength and corrosion resistance. For the body parts, which is the core, cookware surface, and the base, they are all made up of stainless steel for food browning purposes, as steel is a good conductor of heat. Cast iron are also used on the surface for state resistance. Advantages of using alloy for cooking pan. The first one is, alloy is a good thermal conductor. Metallic substance has the ability to conduct heat and electricity due to the presence of free-moving electrons known as the sea of electrons. Most elements vibrate when being heated and has the ability to conduct heat. However, metals are significantly better and faster at conducting heat due to the presence of electrons that are free to move. As you can see in this video, when heated, metal atoms vibrate vigorously and so does the free delocalized electrons in blue. The electrons gain kinetic energy and collides with itself and also other metal atoms. This causes the transfer of energy from one end to the other to be much quicker in metals compared to other elements. Number 2. Electrical conductivity. Some households use induction stove as opposed to the conventional gas stove. For a pan to work on induction stove, it needs to be able to conduct electricity. Here's how induction stove works. When copper core underneath is supplied with high frequency of alternating current, it generates an oscillating magnetic field. When steel pans are placed on the ceramic top that covers the core, the magnetic field from the core will induce small currents in the body of the pan. Iron, which one of the components of stainless steel, is a poor conductor of electricity when compared to copper. So the majority of the energy from the small induced currents failed to be conducted by iron atoms. Thus, it is converted to heat and the heat is used for cooking. Lastly, high melting and boiling point. Alloys or metals in general have high melting and boiling point because metallic bond that they possess is considered strong. A change of physical state can only happen if the energy supplied is enough to overcome the forces of attractions between metal ions and delocalized electrons. Since metallic bond is strong, more energy is needed to break down the bond, hence the high melting and boiling point. This is important so that the cooking pan will not sag, warp, or eventually melt when left on stove for too long. That is all from us. Thank you.